Okay, class, here we are, lesson 6.5. I am not here, but I am on YouTube in a not yet viral video for you to get through lesson 6.5. So what we've done several ways of solving quadratic equations, taking square roots, factoring, and the quadratic formula. Now what we're going to do is look and see what happens when you're presented with a quadratic equation and you're not told which method. So picking any method to solve a quadratic equation. So if we look at it, something like this. So the first thing we did was solving by square roots. The big key for you there, if you saw something squared that you could isolate, then you could solve for square roots. Solve used by taking square roots, sorry. So if I look at this, I obviously see something squared, x plus 3 squared. So if I could isolate that, so if I could change this to 2x plus 3 squared equals negative 5, and then I could divide both sides by 2, like such, and then I would get what, x plus 3 squared equals negative 5 halves. So now it's pretty easy to take the square root of both sides. So if I take the square root of both sides of this equation, so square root of both sides, then I'm going to get x plus 3, because you take the square root of something squared, is going to be equal to plus or minus the square root of 5 halves. Sorry, that's negative 5 halves. Let me back up. So the square root of negative 5 halves. And so that's going to be x plus 3 is equal to plus or minus I times the square root of 5 halves. Solving that for x, x is negative 3 plus or minus I square root of 5 halves. Okay, so that's just solving using the square roots. Like I said, it's really practical when you've got something squared on one side of the equation. The next thing we did was solve by factoring. You can only solve by factoring, here's a big clue, if something is factorable. So in this case, we can look and see if we find factors or if b squared minus 4ac is a perfect square. So let's do something, let's just factor or try to factor. This would factor if I could find two numbers that multiply to a negative 10 and add to give me a negative 3. Okay, factors of 10 are 1 and 10, 2 and 5. So it looks like if I had a 2 and a 5 and the 5 were negative, those two numbers would multiply to negative 10 and add to negative 3. So that means this can be written as x plus 2 times x minus 5 equals 0. Two things multiplied to be 0. That means that x plus 2 equals 0, or x equal negative 2. That's one solution. Or if x minus 5 equals 0, then x is equal to 5. Okay. So if it's factorable, I'll get those two solutions. So you can tell if it's factorable if you can find the factors. The other clue was the discriminant has to be equal to a perfect square. So in this case, b squared minus 4ac, that's going to be negative 3 squared minus 4 times 1 times negative 10. So that's going to be 9 plus 40, which is 49. That is a perfect square. So this will factor, okay, because of the discriminant being a perfect square. And then the other method that we talked about was using the quadratic formula. So the quadratic formula will always work, okay? So brainstorming here, this is where you can interact with yourself since I'm on video, but think about it. What are the pros and cons of each of these methods, okay? If I look at the square roots, this is pretty quick, okay? And, it's, less arithmetic. That's one thing I can think about. So, the downside of this, it only works, so it only works when you can isolate an expression squared, okay? So I can only, when I get x squared equal 21 or x plus 2 squared equal 49. So it only works when I can get that specific use case. Solving by factoring, okay, that's pretty, I think that's also pretty quick. But it only works, you know, and this is rocket science, it only works when what you have is factorable, okay? Or when b squared minus 4ac is a perfect square. So it's a limited use case. Quadratic formula, the good thing about it is that it always works. The negative thing about it is just that, you know, it takes a little bit more time and, you know, it's more arithmetic, okay? So people don't like to lead with the quadratic formula because if one of these other methods works, it's usually quicker. So we want to try to determine if square roots work, that's going to be the quickest way. If factoring works, that's the quickest way. If neither of these work, then I'm going to have to use quadratic formula, okay? So can we quickly determine if one of the other methods works? If so, we'll use it. If we can't determine if that's quickly, then we'll use quadratic formula, or you could always use quadratic formula, okay? So generally speaking, if we can solve one of these other methods, we're going to do that first. So let's get some practice looking at something and determining what's the best method to solve it. So in this case, when I look at this one is like handed to you on a silver platter, something squared equal 25. I'm going to solve this by taking the square root of both sides, okay? So this equation is just begging for you to take the square root of both sides. So if I take the square root of both sides of this equation, so x plus 5 squared equal the square root of 25. When you take the square root of the left side, you'll get x plus 5. And remember, when I take the square root of a variable expression like this, I'm going to have plus or minus. What's the square root of 25? That is 5. Solving this for x is equal to negative 5 plus or minus 5. So let's figure out what those two numbers are. If I take the plus sign, negative 5 plus 5, that's 0. If I take the negative sign, negative 5 minus 5, that's negative 10, okay? So that's my solution. You could write this x equals 0, x equal negative 10. Those are your two solutions. Okay, pretty straightforward. That one I can figure out by the square root, okay? So look at the next one. I can't take square roots of both sides because I can't isolate the square term. I'd still have this x term. So that's not going to help. So you can pretty much easily recognize a case like number one, when you've got something squared or can isolate something squared with no other variable, then take the square roots. Here I don't have that. So my choice is either I factor this or I use the quadratic formula. So is it factorable? So what you could do is just start off saying, okay, can I find two numbers that multiply to give me a 7 and add to give me a negative 6? Okay, the only factors of 7 are 1 and 7. So if I multiply those, I get 7. If I add them, I get 8. That doesn't quite work. Or you might say, what if both these numbers were negative? I multiply those, I get 7. I add them, and I get a negative 8. So that can't work. So these are the only factoring possibilities. So this cannot be factored. The other way you know this cannot be factored, you can say, what is b squared minus 4ac? So that's going to be negative 6 squared minus 4 times 1 times 7. So that is 36 minus 28, and that is going to be 8. That is not a perfect square. So when I take the square root of 8, I don't get a rational number. So I know that this cannot be factored. So I know it cannot be factored. So my only hope is the quadratic formula. So I know it cannot be factored because I tried to factor and none of the possibilities worked. Or when I looked at the discriminant, that's not a perfect square. So now I have to use the quadratic formula. x equal negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So x is equal to negative b, so b is negative 6, so it's going to be the negative of negative 6 plus or minus the square root of b squared minus 4ac. We already calculated that. That is 8. Okay, so we've simplified that a little bit over 2a, and a in this case is 1. So this is x equals 6 plus or minus the square root of 8, all of that over 2. So this is 6 plus or minus, remember 8, I can write the square root of 8. That's the square root of 2 times 4. Square root of 4 is 2, so this is simply 2 square root of 2. So 6 plus 2 square root of 2. And so to simplify this as best I can, this is 6 over 2 plus or minus 2 over 2 times the square root of 2. So this is 3 plus or minus the square root of 2. Okay, so that is the way to solve this particular one. There's no other shortcut. The only method would be quadratic formula in this case. So let's look at the next one. My choice is, can I factor it? Or if I can't factor it, I'm going to have to use quadratic formula. If I factored it, I would have to find numbers that multiply to give me 5 times 24, which is what, 120. So factors of 120 that also can be combined to give me a negative 10. So that's a pretty large number. So I'm trying to think, can I do that off the top of my head? Factors of 120. I'm thinking like, okay, I may skip that and just look at the quadratic formula and see what that one does for me. So quadratic formula, so b squared minus 4ac, that's going to be equal to negative 10 squared minus 4 times 5 times 24. Okay, so this is 100 minus, and this is going to be 20 times 24, so that's, I think that's 480. And let's see if that's right. So 20 times, let me just double check. 20 times 24. Yeah, that is 480. So 100 minus 480, this is minus 380. So now I realize I'm going to have to take the square root of b squared minus 4ac. That's a complex number. So quadratic formula is the only way this one's going to work, okay? Because I'm going to have I in my answer. So x is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So x is equal to negative b, that's going to be 10 plus or minus the square root of negative 380, all of that over 2a, so that's 2 times 5. So that is 10 plus or minus I times the square root of 380, all of that over 10. Now, can I simplify the square root of 380? So I'm just going to say if I divide 380 by 2, that is 190. Divide that by 2 again, and I get, I think, 95. And if I divide that by 5, so that is, so 5 will go into there one time, 19 is that, okay. So 380 is 2 times 2 times 5 times 19. So I can simplify the square root of 380. So the square root of 380 is the square root of 4 times 95, okay?